Welcome to Dividing Radical Expressions. To simplify a quotient involving radicals, we do something called rationalizing the denominator. And this actually will not feel a lot like division, but it is how we handle division with radicals. Here's what we'll do. For a single term denominator, we will multiply the numerator and denominator by a single radical that makes the denominator a perfect nth root. If the denominator involves a sum or difference, then we'll multiply the numerator and denominator by the conjugate of the denominator. Let's go ahead and try both types of these. Number one, we have 3 divided by the square root of 7. Remember, we're not allowed to have a square root in our denominator. So when we look at this, we want to think, wouldn't it be nice if we had 2 factors of 7, because that would make the radicand a perfect square. So what we can do here is multiply the denominator by another square root 7, as long as we do the same to the numerator. Now when we multiply this, we will have 3 square root 7 divided by the square root of 7 times 7. Well, this is now a perfect square, so the square root of 7 squared will just give us 7. So this simplifies to 3 square root 7 over 7. Now be careful here, we cannot simplify these 7's. This one is underneath the radical and this one's not. Let's take a look at number 2. Notice we now have a cube root in our denominator. So we want this denominator to simplify perfectly, which means we need 3 factors of 2. So what we can do is multiply the denominator by the cube root of 2 times 2. Notice this will give us 3 factors of 2, but we must do the same in the numerator. So in the denominator we'd have the cube root of 3 factors of 2. Now let's take a look at the numerator. We have this 2 outside the radical, and then inside the radical we have 4 times 2 times 2. Well, 4 is 2 times 2 itself, so this would be 4 factors of 2. 2 of these from the 4 and 2 of these from here. Let's go ahead and simplify. We have 3 factors of 2 here, and we have 3 factors of 2 here. These are our perfect cube factors, which means our denominator will simplify to one of these factors, or 2. And then in our numerator we have this 2 outside the radical, and then this simplifies to another 2 outside the radical, and we're left with the cube root of 2. Now we do have a common factor of 2 between the numerator and denominator, so this simplifies out. So we're left with 2 cube root 2. Now let's take a look at the type where we have a sum or difference in the denominator. And the procedure to eliminate the square root in the denominator is going to be to multiply by the conjugate. Remember, the conjugate would be square root 2 minus 3, and of course we must do the same to the numerator. Let's go ahead and multiply out the denominator first. Here we'd have the square root of 2 times the square root of 2 as the square root of 4. Now these are conjugates, so the next 2 products should be opposites. The next product will be a minus 3 square root 2, and then we have a plus 3 square root 2, and then we have 3 times negative 3, so that'll be minus 9. Notice the 2 middle terms are opposites. Those sum to 0. Let's go ahead and take a look at our numerator now. We'll distribute the 5, so we'll have 5 square root 2 minus 15. Okay, let's finish simplifying our denominator. Square root of 4 would be 2. 2 minus 9 would be negative 7. Then our numerator is 5 square root 2 minus 15. Now there are a variety of ways to leave this answer. A lot of times textbooks don't like to have a negative in the denominator, so we could rewrite this as 2 separate fractions. We would have negative 5 square root 2 over 7. And here we'd have a negative 15 divided by a negative 7. That'd be plus 15 sevenths. Or we could also rewrite this now over a single denominator where the 7 would be positive. You should be aware there are a variety of ways to express the final answer if you're trying to get your answer to match a specific form. Let's go ahead and take a look at the last problem. I need some extra room, so I'll go ahead and erase these last 2 forms. We need to multiply the numerator and denominator by the conjugate of the denominator, which would be 2 square root 5 minus 3. I always like to start with the denominator to make sure. So the first product will be 2 square root 5 times 2 square root 5. That'll be 4 square root 25. Now the next two products should be opposites. Let's just check that. This would be a negative 6 square root 5, and this would be a positive 6 square root 5. Those are opposites. They'll add to 0. So the last product would be 3 times negative 3, or minus 9. Let's go ahead and multiply out the numerator. 1 times 2 square root 5, 1 times negative 3, negative square root 2 times 2 square root 5, that's going to be negative 2 square root 10. And then lastly we have negative square root 2 times a negative 3, that'll be plus 3 square root 2. Be careful on these products. Remember, we multiply the coefficients together and then we multiply the radicands together. Let's go ahead and simplify this. The square root of 25 would be 5, so 4 times 5 would be 20. 20 minus 9 would be 11. None of these square roots in the numerator simplify, so we can just go ahead and rewrite these. But I will put the minus 3 last. So we have 2 square root 5 minus 2 square root 10 plus 3 square root 2 minus 3 all over 11. I hope you found this video helpful. Thank you for watching.